Good morning. Just morning. Oh, that's loud. Let me turn me down. That's a bit better. How's it going? Who's out there? What we got? Checking on me stream health. Everything's working all right. Everything seems to be okay. I don't have much of a plan today. Plan is, I've got a couple of little kits I might try and build. And just mess around and tinker with some stuff. Big, huge pile of computers to sort out too. I've got all my cameras set up. Let's have a look if they're all working. Including the microscope. We've got some small things to build today. Let's give this a try. So, let me flick you over to the camera view. Yeah, that looks good. Shoulder cam. What's this one? Top down? Should be top down. Yeah, and we should have the microscope as well. Seem to want to change to that one. Maybe the batteries are going in this little remote. Oh yeah, that's the microscope. Let's have a look. The power's on. Should be it. Oh, it's not charging. There's a problem. No power to the microscope. It won't do. Bear with me. Let's jump back over to... I'll flip it back over to the shoulder cam. See if we can get some power to this microscope. There we go. Better. Good, I have the microscope here on channel 2 now. Yeah, lovely. And yeah, it works. There's an SD card. Oh, nice. Alright, what are we doing then? Plan was to build. Got these little kits I bought from Japan. Little chip kit things from a little like hardware, a shopping mall with lots of little hardware, electronics, tinkery, creative shops in there. We're selling these things. So I've got this here, which is like a LED SMD little book you can build. I think it's just a flashy thing. It's got a little chip on there for controlling some flashing. It says something about flicker chip LED. And then this is like a sort of a little Arduino thing. It's called Ichigo Jam, which I thought looked pretty cool. The guy had it playing some daft little games, little keyboards plugged into it and things. It looked quite fun, so I thought we could build that. We've also got this Christmas decoration, a little snowman thing. That might be fun too. But before we get into any of that, I've just... Where's my coffee gone? Just tried to get my chat screen working. I've got a little screen here for chat and the plug. This wasn't working at all, so I thought I could smash this to bits and just try and figure out what went wrong with it. Oh, we got a first chatter and it's a bot. That's nice, isn't it? So let me put this in the vise. I'm going to smash it open, crush it open, smash it to bits. Let's flip you over to this screen. Oh, hey, how's it going? We've got a real person who's not a bot. Thanks for joining. Thanks for saying hi. Just going to mess around today for a couple of hours and break some stuff and build some stuff. So this plug stopped working, which was for this screen. I thought we could put it in the vise and smash it to pieces and try and figure out what went wrong, since I don't think it's going to come apart very easily. Nice. That's a good crack. If it's not broken, it definitely will be after this. Alright, we're in. So, there's quite a lot going on in here. It's interesting. Well, I'm absolutely right with you. I've got a coffee here. And I thought it might be nice to, first of all, look at how this is built in a sort of Big Clive kind of way. but also to figure out what's gone wrong with it. So first of all, we've got red wires for live and neutral. That's always good, isn't it? There's a chip involved there. It's obviously an AC/DC circuit, and it will be rectifying and transforming. Looks like there's is that an optocoupler on each side of it? I wonder what went wrong. There is a fuse there. It doesn't look like it's damaged in any way. Maybe we could put the multimeter on it and see if there's any continuity over it. Well, the fuse isn't dead. That's positive, at least. I don't see anything that's obviously blown up. But it was definitely not kicking out anything, really. I wonder if the coil might have shorted some windings. Let's check the resistance over that. Mega ohms. Why shouldn't really be giving anything, should it? This side is open. Nothing on this side. We should have very low resistance on these. 2 ohms and 0.2 ohms. Okay, yeah, that's a longer wire and a shorter wire. So I wonder what went wrong. I wonder what went wrong with this. I don't really want to test it on the bench because that means making it go live and potentially hurting myself while messing around with the stream stuff. And I know it's not just the LED because it's definitely not kicking out any voltage. Could diode test this big diode. See what that comes up with. Interesting. Okay, that doesn't seem right, but maybe it's because I'm testing it in circuit. Should we take this diode out and have a look? I'm not fantastically good with power supplies, if I'm honest. We do get them in occasionally at the repair cafe. Coffee. I'm just gonna ungracefully wrench this diode out. Quite a lot of heat. Oh, and out you get. Nearly got him. I'm being lazy here and not using the vise. Okay, he's out. Okay, what about a diode test on it now? Bring the multimeter back. Well, I think that could be a problem. The diode is, let me check the continuity over it. Diode is completely shorted internally. This guy. Can we read it? See if we can focus on it here. That is a diode now, isn't it? It must be, yeah. R540. I don't think it's just R, is it? It's SR540. I don't think I've got such a diode anywhere. Maybe I can have a quick look on the internet. Scoot back over here. Hello. I'm just going to do a bit of Googling. SR540 diode. It's a 3 amp 50 volt rectifier diode. We do have some diodes might meet that sort of roughly. In the building things drawers. So in here somewhere. We might just have. We've got this one. Now this is an IN5820. Should we ask AI? Can I replace it with an IN5820? I wonder. No, I can't. Max forward current 3 amps. Peak reverse voltage 20 amps. Honestly, I don't know. I think a rectified diode maybe is just a bit more beefy. But you know what? This power supply is for the bin anyway, so why don't we let's just shove this in and see what happens. That'll be fun. Okay, let's go back over. So this will go in, but it's just rated a little bit less. Means I have to take this guy out of here now. Yeah, we can do that. Let's go back to overhead. See if I can get this out without burning myself in a quick, lazy way. He's out. Yeah, the joints are clear. Oh well, who knows, maybe we'll actually repair something here. Polarity is marked on there. It's handy. And I think it's just to be one of these kind of standing upright arrangements. This works, I'll order some of those diodes and I can have my plug back. At the moment I'm just I'm running my little screen here off the bench supply, which I might need later on. Alright. That's in. Where's my solder gone? Here we are. It's probably a good question for AI, that. What's the difference between those two kinds of diodes? Alright. And I'm getting in a messy with my screens. We just... Okay. Yeah, it's fine. Right, let's solder. Of course, the worry is, you know, another failure might have caused this diode to go open circuit. Ooh, we need a lot of heat for this. Rectifier don't handle much more current, but has much slower switching speed. Okay. Good to know. We'll see what happens with it. It might just go up in smoke. Okay, that should be pretty well attached. Ooh, hot. Hot, hot, hot. Snip these legs. Ping. Ping. And your eyeballs. These wires are piddly, aren't they? So, what shall we do? I need to plug this in. I don't particularly want to be handling it while it's plugged in. Ooh, that's nice. What do you think of this? My capacitor here. That's just a solder splash from the factory, isn't it? I think. I don't think the capacitor is particularly bulging or anything. That's okay. What else have we got on here while we're looking? So that could be some kind of rectifying jobby. Diodes, resistors, capacitors. There's a transistor down here and some other bits that all look okay. I'm assuming that's an optocoupler. I don't know how liable they are to failing. And then some sort of brains here for switching, maybe? I guess. Okay, I guess I should reassemble this a little bit. I've already broken the case. Smart of me. I'm shoving it in the vise. Is that right? There is an LED hole on this, yeah, there. The board wasn't screwed in any way. It's sort of sandwiched. Will it clip back together? Yeah, it did. Alright. Now what happens? I'm gonna have to plug it in. Okay, we get smoke. Head over to this view. I guess I'll plug it in over here and see what happens. Hey, the LEDs come on. Can you see that? Yeah, you can. Which means we should get 12 volts from the end here. Obviously there's no load on it right now. Enter positive. Five volts. Oh, hang on, that's not right. Okay. Have we fixed it? I don't know if we have. Of course, there's no load on that. Should I plug it into this screen? This is what it's for. Let's just try it. Oh. Now the light's flashing. Okay. It's probably the switching speed, do you think, of the diode? I don't know. It's obviously not working. We almost got it. Maybe I need one of those proper diodes. Let that capacitor discharge. There it goes. Maybe I'll order one. Maybe we can fix that. another time. Put this on the pile. Tidy up a little bit. I would say that this diode is definitely goosed. This bin's normally for failed components. All right, so what we're gonna do, let's build something. Let's build this. Bought this in, like I mentioned, in Tokyo. I kind of don't want to open it, it's such a good souvenir. All the way from the Electric City. How's your katakana? I think this is Flickera chip. Flickera chip LED. Let's open it up. This is how lazy I am. I'm not going to get the scissors out. So we have completely Japanese instructions. I'm hoping we're not going to need them. Oh God. Okay. And here's our little circuit board. Should we look close up? Is it EL kit? LE kit. LE kit. LKST8. Tiny little PCB. That I need to bring you up a bit to fit the whole thing in. Cool. 2 variable resistors, DC in, 1 transistor, a chip, capacitor, the surface mount LED. This could be fun. Okay, how are we going to do this then? I think I should build it totally under the microscope. So maybe I can bring that in without unplugging anything. I can move the top camera out the way for now because we don't need that. It's fighting me. Better. I think some blue tack might be in order to hold this in place. Of course, it's not ideal, is it, using blue tack, because the blue tack's gonna cook with the hot air. But this will blow away otherwise, this tiny little PCB. Right, let's see how we go. I've got a slight problem, which is my solder paste has gone off. But I've got some good flux, got a hot iron, and I've got a hot air gun, which I need to pop a nozzle on. Okay, here it is, hot air. Ooh. Now, where's my components gone? I think I've just put this on top of them, have I? No, I haven't. Where are they? Bag of bits. Bag of bits is here. So here's our little chip. Maybe we should do the chip first. That was weird. I could have sworn that chip landed in my hand and then it wasn't there. Let's not lose the chip. There's no spares. Alright, and I have to get the scissors out to get into this. Stop being lazy. God, what have they made this packet out of? Hey, it's out. Okay. Tweezers, anyone? Tweezers. I don't look after my tweezers very well, and they invariably get sticky like this. Makes it really hard to build anything. Flip it over. Turn over, thank you. I assume that arrow... Hang on a minute. Yeah, the arrow must be pointing to 1. Oh, these are so sticky, that's no good. So we're going like this. Should be fine. I need to get a tiny little bit solder paste on here. As I said, my solder paste has gone off, which is no good. I can turn my chat window back on in a minute. And you get... Okay. Okay, I'm back. Hello. Hello. Floating fat man. How are you? Wipe it with some IPA. Okay. Let's clean it. That's a good idea. And one for good ideas. Okay, can I get a little bit of solder paste out of here without making a big mess? This paste has really gone off. This isn't going to go very well. Oh, the tweezers. Yeah, sorry. Yeah, good idea. Good idea. I will. Promise I will. Here's a little bit. I don't want much because I always make a mess. And a little bit more. That's probably fine, isn't it? Okay, tweezers. Let's do what you said. It's a good idea. Should be a bit better. Good. Let's see if we stick now. Here it comes. Oh, it didn't stick. Wow, lovely. Now, I had a lot of trouble getting this solder paste to melt last time I built something with it, so let's just get me hot air nice and hot. Put the flow rate down a bit. I hope this isn't too loud. I've put it up to 400. I would preheat it, but it's such a small board anyway. I feel like the whole thing's going to get hot all the same. I'm just trying carefully sort of wash around the board for a bit before focusing it all. I'm not hopeful that this board is particularly high quality. It was a couple of quid. Flow rate's a bit high. It's trying to blow it away. Yeah, baby, melt. Hey, not too bad. My problem, my doesn't reach. There we go. We're a bit off center, but they gave me such big pads to work with. It's gone quite well, I think. We'll tidy it up a little bit. I'm going to put some flux on, but I'll just let it cool. I'm curious what this chip is. Should we look it up? Let's scoot back over here. Hello. Let's Google it. Let's Google that chip. It is a SN2333. SM, is it? SM? Yeah, I'm with you. I'm going to touch it up in a second. Is it SM? SN2333. What is that? What does that do? Anyone any good at finding data sheets? SN. I can't find any chips called that. That's funny, isn't it? Huh. It could be that first number. Let's just pick up and get closer. F1822. Oh, I've made a right mess of that, haven't I? I need to put the iron on there. F1822. Let's look that one up. What's it? 12F1822. Oh, there it is. It's a 12F. It's a microchip. I think. Huh. I found a product brief. It's an 8-bit microcontroller, apparently. That's interesting. Although the 8-pin version only seems to have 6 I/O pins. 6 I/O pins and voltage and ground. Okay, so they've programmed this with some custom logic, I guess. That's interesting. Where's the plunger gone for my solder, for my flux? Let's try and tidy this up because I haven't done a wonderful job here. It's nice to not have to use flux pens. Those aren't very good. All these bits. Where are those bits coming from? I think that's pretty good. Very nice. Okay. Let's move on. Let's see what comes out of the packet next. All the other bits are together in this little bag. Blue tack gets everywhere. So what have we got? That would be the LED, I guess. Sorry for the glare. I've reduced the glare. A little bit better. There's a transistor. They gave me a spare, that's nice. A couple of variable resistors. Resistors? Resistors? Why have they given me resistors? Oh, is that the capacitor? Oh yeah, there's a resistor on there, okay. That's the resistor, that's the capacitor. Okay. I think let's do the capacitor next. Pretty, yeah, that's the right color, isn't it? Orangey. Pretty small package. Yeah, I'm with you, Mr. Fatman. It is the it's a job for blue tack. It just means there's a bit more cleaning up to do. Bear with me, I'm just struggling with this tape. Okay, capacitor is free. He's over here. God, that's small. What size even is that? Oof. That 0603? Smaller? I think they've fobbed me off here with the one with the smaller capacitor than were they intended. What's happening here? 0.1 microfarad. I'm going to get one of my own capacitors down. I must have one that fits a bit better. I've got a little photo book here. Can't really show you this. I'm quite proud of this photo album. Let me go to shoulder view. Yeah, it is extremely small. You get to see the chaos now. Here we go. Here's my little photos. It just contains SMD components. So what have I got first? This is resistors first. I feel like I could inhale this capacitor. It's so small. This is the capacitor section. It definitely said 0.1 microfarads, yeah. I must have some. 100 microfarads, 0.01, 0.1 microfarads. There we go. Courtesy of Mouser. Lovely. We'll use that. Okay. Let's compare sizes. Is it going to fit on that little footprint? Yeah. I think that's better, isn't it? Let's put this one safely over somewhere where I'm not going to lose it. Maybe I can get it back in the original. Hang on. It's delicate. You get back in bed. Can't get it in. There we are. Just live back in there. Okay. I'm going to try and use air again because it went so well before. I'm using a shard of that plug casing as my applicator. That looks okay. Okay, that's probably a bit much, but it's not too bad. Let's get this guy in place. Close enough? Okay. I'm going to turn this airflow right down. Very, very, very low flow rate right now, but the temperature's high. It's trying to walk away. Don't go anywhere. Good. Good. How's that? That's good. Nice. I don't think that even needs any touching up. Okay, let's move on. How about these transistors? Q1. Okay, there's only one transistor. They're giving me a spare, which is kind. The question is, can I get the film off to reveal it? The answer is with difficulty. Yeah, that's a good tip, to hold it down with the tweezers. Maybe I'm scared of doing that because I'm a bit shaky and a bit clumsy sometimes, and I feel like I'm just gonna ping it off. Oh, it's too many things to keep track of at one time. I should try it, really. I cannot get these transistors out of this case. Hang on, bear with me. God, I'm butchering this. Come on, out you get. Out you get. Out you get. Nearly there. He's out. Q1. There he is. I wonder why this is going much better than previously. I think because the last board I put together had big ground planes. Maybe the board just wasn't getting hot enough, and everything just wasn't playing ball. So, let's paste up this footprint. Q1. That's good. You really get some toothpicks. I've heard toothpicks are good for this. Oh god. Blob. Okay, that's fine. That's fine. Okay. Into your forever home, old transistor. Why are you being sticky? Turn around. Turn around. No, don't stick. This must be painful to watch if you're actually good at this. There we go. So are you saying I can push down on there like this? And then heat. Can I stay still? Doesn't this stop it from nicely sort of sloping into place? Lovely. Yes. My tweezers are getting hot. See a rogue bit of solder on the left there. That went quite well. What is that? A little ball of solder. Get rid of that. I think I prefer through hole as well, because shaky hands. Or just lack of experience. It's why I don't like using blue tack with hot air. I'll just have to give it a clean later. Shall we move on to the resistor then? I wonder if they've stitched me up with a too small a package again. Although saying that, well, the footprint looks fairly small. According to the instructions, the resistor is 220 ohms. I can't read any of that. I can read this. Now, this is interesting. That says condenser. That's an old school way of saying capacitor, isn't it? That says condenser. That says transistor. That's the same word. Variable resistor. Okay, no. Elastor. Maybe they just call resistors erasters. Condenser. Nice, I like that. So this should be 220 ohms anyway. Can we read the markings? 221, is that right? I'm not very good with markings. 22 sounds right. 1 is 10, is it? I'm struggling again with this film. Let's get the tweezers involved. There we go. Yes. By the way, I'm sorry if seems like there's a delay. YouTube just seems to have more of a delay than Twitch. And I don't know why. I think YouTube just isn't as on the ball really with this live streaming thing like Twitch is. YouTube seems like it was quite late to the game. Well, here we are, 221. This is small. I don't know who they're selling these kits for. It's not exactly a beginner kit, is it? Oof, dear. Might have a little look in my photo book again. Maybe I can find a 220 ohm resistor that's a 0805 package. Let's see what I've got. I've got 1K, 100 ohms, 10 kilo ohms, 2 kilo ohms, 330 ohms, 22 ohms. No. No, I don't have a SMD. resistor of that rating. That's a shame. Oh well, we'll struggle on with this one then. Just move them out of the way so I can put some paste down. And have a drink. Okay. Here's the applicator. Don't like that word. Not enough. Should do. Okay. Try and get him in place. Damn it. Sticky tweezers. Tombstone. The wrong way around, buddy. Too much paste here, but big pads. Probably okay. Let's get the hot air. See if I can hold this down. This feels delicate. Please don't ping off. All right, not so bad. I don't think it's shorted underneath. I'd be surprised if it has, but I don't trust myself, so I'm just going to quickly put the probe on it. No, exactly 220. Wow, perfectly in tolerance. The specification, bang on. It's good quality parts, I guess. So what's next? Variable resistors. I'm a bit worried about, should I be worried about using hot air on a variable resistor? Am I going to warp it? I don't really want to warp it. Let's have a look at it. So it goes like this. You can see plastic on there too, I think. Oh, I don't know about that. I don't know about using heat on that. The instructions actually tell you to do the whole thing with a... Look at that, they're trying to tell you to solder it like it's a through-hole joint feeding the joint. Interesting. Anything about the resistors? No, nothing specific about the variable resistors. So what's the story here then? Maybe I will use paste. You definitely need enough to flood the pad. I really don't want to melt these because they haven't given me any spares. And I definitely don't have anything that would fit. Really careful not to use too much. And what I'm thinking is, let me just get this right. So it goes that way. Thinking of just holding it down, touching the iron on with those pads. A bit wonky. I think that's good. Well, I haven't given myself much room here. Let's see if we can get it to come in steep because I've put the chip on. What about a tiny little dab of flux on there? Just make sure we've got lots of heat going around the joint. Yeah, I think that looks good. Do the same on this side. Probably good, eh? I will clean up at the end. Why is there a header? Am I expected to program this chip? No, surely not. I wonder what the header's for. Didn't say anything about it. All right. Next resistor, variable resistor. And let's put some paste on. A little bit more. Probably good. Right, which way? Which way? This way. That's good. Should have done these first. Oh god, I'm leaking flux. I didn't pull the plunger back. That's a lot. That's too much. Okay, just touch these up. And not to melt the package. Hopefully I can turn those Let's get a little screwdriver. How little do we need to be? Quite little. This one? Nope, doesn't fit. Maybe this one. No, it's not turning it. I don't tell me I've broken them. Oh yeah. Yeah, that's the right one. I can turn them. Nice, okay. It's great. So now we just have to put the LED on. I seem to have marked one corner. Oh, it's a smart LED, is it? Yeah, it's obviously a color changing one. It's got more than 2 pins. Where is it? Here it is. Okay, he's out. Let's have a little look. We're staying. I'm going to bring you down. Let's have a close look at that. Turn the light on. Which way do I focus this thing? There she blows. Oh, I see. The corner's cut off here. That must align with the footprint. Must be some silicone in there. It's neat. And it must go on like that. Yeah, that'll be it. I wonder how much closer I can get to this and still focus. We're going in, basically touching the lens. Yeah, it's slightly frosted covering on it, unfortunately, so we can't quite get a good clear view. Oh well. Quite interested. Oh, you've Googled it? Go on, what is it? All I know is it's a flicker chip LED. I can't read the rest of it, apart from the word kit. Apologies, I'm focusing. Okay, focused. Now again, I don't want to cook this LED with hot air and melt it. I think I'm going to use the iron again. Let's just put some bits on. and we can place the LED. I think I definitely need to hold this in place. Very good. Pretty good. That looks scorched, but it's just blue tack. All right, where's my toothbrush? Let's clean it. Get the blue tack off as well. I've really put that chip on wonky, haven't I? Oh well, that's okay. Okay, now how am I going to power this? Because I'm using my bench power supply to power the screen. Well, I'm going to need how should I do it? With headers? No, I'll just stick a couple of wires on. And if I could switch you back to overhead for a minute. And we'll put this together. Okay. Ah, that's what I was expecting. That's good. Oh, fingers crossed, eh? I'm just going to get a bit of length of this. And where's black? Where's black? Nice. Solder's over here. Ding. Ding. Lovely. Instructions. It must tell me somewhere. It says here 3.5 volts. So let's start with 3.5, I think. Which means I'm going to lose my chat screen over here, but it's alright, I can still see you on the PC monitor. I've got these alligator clip attachments. Just turn that down to 3 volts, 3.5. I can turn the iron off now. I'll turn this off while I hook it up. These are the worst alligator clips in the world. Okay. This one. Tidy up a little bit. Takes ages to turn off. Turn off, please. Okay, let's just check. Actually, before we do anything, let's check what current we're limited to. 2 amps is probably a bit overkill, do you think? I'm just going to put it to 200 milliamps. That would be fine, I think. Okay, we're hooked up. Now I'm going to cliffhanger you because I need a break for 1 minute. I'll be back in 1 minute. Hello, hello, I'm back. Okay. Okay, I'm back. We're gonna try it out. I reckon what we should do is... Oops. Let's go top down. Top down. Lights off. And I'm going to turn the power on. Let's see what happens. Yay! It's flashing. Lovely. It's too bright in here. Can't really change. Let's go manual on this thing. Did I do that? Change the ISO. Put that right, yeah, let's put the ISO down. Look at that. I should be allowed to put the voltage up a little bit. Alright, that's cool. And what if we tried to change the settings a bit? So VR1 is color. Try VR1 first. Yeah. Blue. There's blue. Red. Green. I like green. Green's the channel color. And we should be able to change the interval. Okay, that's maximum. Obviously it's so fast that it looks like it's just on. Maybe it is just on. Doesn't seem to be interfering with the frame rate. Okay, that's flashing really fast, but it's hard to see on the camera. Do you know what? It's out of focus. Okay, we're manual focus now. Now you're in focus. How slow can it go? That's as slow as it gets. What's that like? 30 hertz or something? All the way up to constantly on. Nice. Okay, I'll put the ISO back. I'm not actually sitting in the dark. Put it back to auto. And we're back. Let's have a look at it under the scope. That'll be interesting. Changing the color. Sorry if you're... I hope no one's epileptic. Let's just put it to... Oh, it's gone to like disco mode. That's cool. Okay, we're constantly on now. Let's go right in. See if we can see the LEDs lighting up. I focus down on this. Yeah, kind of. It'll come right down like we did before. Yeah, you can't really see very well. If I could turn the voltage down a little bit. No, that doesn't help. Not much to see up close. Let's come back out. Focus again. I think that's dirt on the lens, you can see. There we go, we're back. Yeah, I enjoyed that. Let's build the other one as well while we're doing it. How about green? I won't flash it on the screen like that. It's a bit hard to watch, isn't it? Nice. All right. Jumping back. To the shoulder cam. Let's put the lights back on. So that was this kit. Kind of hard to read, slightly too Japanese. The flicker LED kit, and should probably try and be careful not to just let all these parts get all mixed up. So, as there are some spares, as I mentioned. There's a spare transistor, a couple of spare resistors, and I've still got the 2 capacitors, haven't I? Because I use my own capacitor. I guess I can keep this in the bag and put it in the toy box. Nice, that was fun. All right. Let's do the next one. I think I'm gonna do the snowman. That sounds fun. Christmas decoration. It's a bit early for it. I'll give you that. Does it have instructions? Yeah, we've got quite a big instruction manual. Telling you how to do through-hole soldering and things like that. Let's have a better look at it from up here. Maybe tidy up a little bit while I'm at it. This one has a battery. Place for a battery on it, so I'm not going to need the power supply, which means I can put the power supply back to powering my screen. Bear with me 1 second. Okay, should be back. We are back. So here we are. Snowman thingy. Can we read any of this? This is the order in which to build it. Does that first thing say resistors? I think it's resistors, then the switch, NPN transistor. We know what that is. Number 5 is the battery, I think. LED, and then there's that word again, condenser. Capacitors going last. I love that they call them condensers. And there's some little guides on which way to solder the LED. And the capacitors, also known as condensers, and the transistors. They've identified B, C, and E, which is nice. It says base, collector, emitter. Yeah, that's good because they've put the silk screen on. I can't get that wrong. It looks like this is all through hole, so this should be a doddle, really. All right, I'll get a move on. I don't think we have any snow left over here, unfortunately. Oh, how do we do this then? We're going to use the microscope. We probably don't need to use the microscope for this one, do we? I will need a hot soldering iron, so let's turn that on. Need to tidy up a bit. I've made a right mess. I'm not going to need the tweezers for these gigantic components. Ah, they provided a battery. That's nice. I'm not going to need solder paste. I'm not going to need solder. Flux core will do. I'll need my solder. This is all junk for the bin. How did you change the colour of your chat name? Didn't know you could do that. I'm not going to need any extra wires for a while anyway. That's for the bin. I'm getting there. There's me solder. What's this? That's for the bin. Okay, I can move this out the way now. And bring the mat back in. It's better, much more familiar. Interesting they've put a header on here. Am I zoomed in fully? Down. Back to autofocus. What's the idea with this header then? Is it so it stands up? Are you meant to stand it up with a 90-degree header? Well, there's no pictures. Yeah, there's a schematic. That's nice, isn't it? So what is this, like an astable oscillator? Must be. Couple LEDs, switch, battery, easy. I need to translate this sentence, that's way too advanced for me. Let's get the translate out. Hopefully I've still got got Japanese installed. Yeah, I do. Where am I looking here? There. Can be separated by folding along the perforations. Yeah, okay, I kind of realised that. Okay. I like that he's got a flashy nose. Yeah, it's Japanese. Hey, how's it going? I bought this in Tokyo. And this one, which we just built, is a flashy LED thing. And this, which is called Ichigo Jam. And it looks like I saw the guy using it, and it's a bit like an Arduino. like a kind of creative tinkerer's thing. It's got the microcontroller on there already, pre-soldered. It's got some inputs and outputs, and you can code it with, I think, BASIC, a little terminal. I think it has it. It might even have its own terminal. Yeah, and he had little games all set up in this department store in Akihabara in Tokyo. So I had a slightly clumsy conversation with him trying to learn about it and decided to buy one. We'll get onto this one eventually. Now we're going to do the snowman. What is the recommended order then? Recommended order. I think. Doesn't really matter, does it? It's through hole, it should be easy. So where have my parts gone? Parts are here. Oh, this feels so much easier than the last one. Fantastic. Little 2-position switch. LEDs. The long leg's the positive leg, isn't it? Yeah, long leg is positive. Let's start with the resistors though. And I've got... where is it? I've got one of these. I like this. This was a good investment. Looks like we're on the smallest one. Now there's would be 5 resistors. Let's sort these out. Put the LEDs there. Resistors there. Capacitors there. And we've got the resistors down here. So there should be 300 ohm resistors. 2 47Ks. Well, those 3 are all the same. And these 2 are the same, so I assume they're the 47Ks. You can't see, sorry. Assume they're the 47Ks and they're the 100Ks. But let's just measure. Always a good idea. I'm expecting 47K. Close enough. Close enough. And I'm expecting 100 ohms. Close enough. Close enough. Close enough. But will they fit in my bendy jig on the shortest? No, they won't. I can get them in there. In this one. No, these are the 47s. Is that going to fit? No, it's too wide. Way too wide. Okay, I'm just going to have to bend them at the casing. Shall I lock the focus in? Yeah, that's a bit better. It's a bit nicer too, less glare. So these are the 47s. This is soldered down, and it's taped down, hang on. Okay, that needs to be soldered. Let's get that out of the way. God, I've bent it already. But these resistors barely fit. Okay. They don't feel like the best resistors in the world. At the 47k there. I kind of don't want to overwork these because they feel quite brittle, to be honest. Let's just put them in place like that. And they're very, very tight fit. Yeah, this one's not looking too good, but that's the way it is. Put our 100 ohms in. Why have they done this? Why have they provided basically the wrong package? Doesn't feel right applying that much force. Okay, at least that's taken it nicely. Good. Mind me just messing with the focus. There's a 100 ohmer going in. And the last one. All right. Let's solder up. Very nice to build something which is small and not an Amiga, which takes 12 hours. You get to see it working very soon after you start building it. Alright, we've got our resistors in. Let's go with transistors now. What are we on? K343C3198, whatever that is. Nicely bent into shape. So these won't be doing the splits. Look, they fall right in. Lovely. I am still going to bend them out a little bit so they don't fall out when I flip it over. And with TR1. I assume they're the same rating, they came off the same reel. Desperately need a solder fume extractor. Should have thought about that when I was building this room. Could have put a proper one in. Very nice. Flying together. A couple of capacitors then. Are they the same rating? What have we got? We've got 47 microfarads and 47 microfarads. They are the same, okay. So, polarity is nicely marked on, and they sit flush. That's lovely. I like that with a capacitor. Do have a couple of replica PCBs sitting next to me. One is for a ZX Spectrum, one's for a ZX81. I can't decide if I want to give them away, sell them for charity, or build them myself. Of course, building it yourself is just going to take so long. You have to buy lots more parts. It did come in part of the charity donation, which I'm working through very slowly. Maybe it'd be best to sell it for charity. That's looking good. We've got our LEDs now. So they're suggesting, from the diagrams, he has a yellow nose. He has a green bottom button. The red top button. I am indifferent to which order these go in, so that's fine by me. Let's put it together. Oh, my cat's coming to join us. Cat. She's just looking out the cat flap. What's happened to my playlist? This is a bit weird, isn't it? Meant to be chill background. Sounded a bit Shadow of the Beast. So what's left? Just the switch. And the battery holder. So switch going in. Maybe a little dab of blue tack. That's the cat going out. The neighbour's cat's been on the prowl today and he's a baddie. He attacks her. I reckon she's going to come running in a minute with a puffed up tail. Lovely jubbly. Now just the battery holder. Is that going to stay put for me? I don't think it is. Let's put the blue tack on. That's ground. That was taking an extra second to heat up. And there he is. There's our snowman. Should we dim the lights again? We can test this one. He'll be ready for Christmas. That'll be his moment. She's coming around way too quickly. Here we go. It won't go in. Hang on a minute. ISO. In a minute. Yeah. Quite dim, really, isn't it, those lights? That'll go with PCB Wave sent me some Christmas decoration PCBs as well. I wonder if we could tune it and make it faster, overclock it a little bit. Oh, of course you can, you just need to change these capacitors, I suppose. How would you make a oscillator like this go faster? Bring you back into the light. Suppose you just need to have some more light. You would just need smaller capacitors, right? Put the same value in, but maybe 4.7 would be twice as fast, I guess. No, I won't mess with it. I'm happy with that. Don't really know what to do with separating it. I guess you could then use some wires to have him on display and hide the circuitry. Circuitry is the most interesting bit. Off. Lovely. We've built two things. That's good. What else can we build? I've got one of these. Still, maybe we could build this. Let's put these out of the way. You can see the chaos. You might be wondering why I've got a Spectrum chipset loose over here. That's because I'm fixing one. Just had some dodgy work, so I've ripped all the sockets out. However, it does present an opportunity to test this, which I'm quite excited about. It's not my creation. Oh, good idea, yeah. Yeah, potentiometers. But would you not get a strange duty cycle if the resistors were different? Yeah, you would want them to be the same for an even flash, I guess, or would you get a strange duty cycle? Cat's back. So this, can you read it? Pico Z80. This is a drop-in replacement for the Z80. How about that? Running on the old RP 2350 80. Allegedly, cycle perfect emulation of a Z80. Can't wait to try that out. Hasn't been tested yet in Sinclair computers. So cross your fingers. I'll be working on that soon. That next video. Let's get on with our building. So this is Ichigo Jam. You can go to ichigojam.net, and I imagine you'll see some of the projects people have made with this, little games and things. Yeah, tell me about it. I'm thinking of doing a project with the Pico CP with that microcontroller. I don't know if you've seen, but I've built an Arduino interface for the Spectrum, and I used an 80 mega chip, which is the Arduino one, and it's just too slow. So I've had to add loads of external circuitry to get it to do what I want, but if I just used an RP chip, I think I could do it all really easily. The only problem is going to need level shifters, aren't you, for working with the Spectrum, because you'll need to shift 5 volts to 3.3 volts. Like what Dr. Gussman did with the logic analyzer. So this plugs in the Spectrum, and you get decoded logic analysis, but you need lots and lots of level shifters. So luckily I've got a few bags of these from building this, so hopefully I can build one. What I want to upgrade is this. I need a new version of this. This is the Arduino interface. Ignore the patch, there's an error in the design. But all of this circuitry is there because this thing is too slow to snipe the data bus at the right times. Don't get me wrong, it works. I made a rumble pack for the ZX Spectrum with it, which is quite cool, like a vibrating controller. And you can make it reactive to what's happening in the game without having to modify the code. Yeah, I think one of these with an RP chip on, that'd be really neat. You'll be able to do all sorts with it. Probably get a HDMI feed out of it. It's so fast. Anyway, I digress. We're going to look at Ichigo Jam. This is a neat kit. Look, it's come with stickers. That's really nice. Here's the components. So this is sockets, I guess, and a speaker. Yeah, and this is, oh, there's sockets and switches in here as well as the passives. And we've got lots of bits of paper. This one looks important, doesn't it? Shall we read it? Do not give this to children under 3 years old. It's only intended for use in Japan. Small parts. Do not accidentally put them in your mouth. Do not use damaged products. Yeah. Nothing interesting there. It's just a safety notice. And just a part list. Sound something reference. Sound something reference. Sound expansion reference, okay. Connecting the sound pin of the Ichigo Jam. By connecting a piezoelectric sounder audio jack or sound terminal to the sound pin, you can control the sound with play or beep or tempo. Okay, that's good. And then it's got some extra information here about what it can do. So you can play sounds of specific lengths. This is the code you need to use to do it. Oh, that's nice. You can just type in a little tune. Nice. Well, I'll keep hold of these documents. Ichigo Jam Basic. It looks like they've kind of developed their a version of Basic just for this. So here's all the commands and what they do. print, play, load, save, run, wait, LEDs, loop, video. Cool. And this looks like examples of how to use the basic. And then what have we got here? This is what it's going to look like. There's a little how to solder. Parts list. And then here's how to hook it up. There you can see it's got its own little terminal from a composite video output. You can type in the code directly with the USB keyboard. How nice is that? Ichigo Jam. Okay. Let's start building then. Giga device, that says. IchigoJam by jig.jp. This is fantastic. Quite excited about this. Okay. Right, let's just start putting stuff in then, eh? Where's my little assembly instructions? Let's make sure I get some bits right. Okay. What am I going to start with? I'll start with the lower stuff, so maybe the resistors. So we've got R1, R2, and R4. $470, 100, and 680. Okay, I need to identify which of these resistors is which. So let's just measure one and fit that one. Starting with this guy, without blocking the screen. $460. That'll be the 470 one. I wonder if I've got a good size on my jig. Probably that one. About to lose the battery on this camera. Give me a second. Let's change it. Right, we're back. So this one was 470, right? I've bent that completely wrong. Lovely. What's the next one measuring? $680. That's R4. Should be two more. What's this one? That's 100 ohms. That must be R2. And this last one, this must be 10K. It's the only one that's left. Yep, it's about 10K. Okay, let's start soldering. Okay, we're away. Good start. Now, let's do the capacitors. C1, C... No, there's 4 capacitors here, so what's that? C1, 2, 3, and 4. Okay. C1 and 2 are 10 microfarads, and C3 and 4 are 15 picofarads. So let's see, that says 15. That says 15. And these two must say 106 and 106, okay. And 15 was C3 and C4, so that's here. And they fit just right. And now C1 and C2, 10 microfarads. That's nice. The parts list also tells you the markings, so it says 106 in the parts list. All right. Going together nicely. Got the feeling when I was talking to the guy in Tokyo about this kit that it was for kids. But I don't know, you don't see any... Do you see much like this for kids over here? I don't know, to be honest, I don't have kids. I can't see a kid soldering it together. Maybe it's different in Japan. Okay, capacitors are in. What have we got next? There's a little clock here. Looks like it's 8 megahertz. I guess. Where's the crystal going now? Sorry, I'm having a blind moment. There, XT1. Right in the middle. Oh, and these are the load capacitors. Okay. That makes sense. Okay, we have a clock. A little bit wonky, sorry. Never mind. Transistor? Just the one, I think. Yep. IC1. IC1? No. Yeah, they call a transistor IC1. Interesting. I think it's just a transistor. It looks like one. The transistor really an integrated circuit? I don't know. Lovely. What's next? What shall we do next? The switch? We've got this little temporary switch thing. Should these click in nicely? Yeah. Nice. I'm going to assume this is a reset for the microcontroller. Probably say on it, does it? No, it just says switch 2. That's okay. We'll find out. There's a slidey switch here. I'm not clear what that's for. It's got a lot of positions. And it's called switch 1. Right, it says, no, S1, SW1. Slide or switch, slide switch. No, there's too much complicated stuff there. Let's have a look, let's translate it. Didn't tell me what it does. What is that switch for? Okay. I'm gonna have to read the instructions a bit more. Well, I assume I need to fit it anyway. Eyes. Seems to be symmetrical. Pretty much. There is a little hole on the side there, but can't really see from any pictures if it particularly matters. There's no special notes on the switch, so I'm just going to go with this. That's fine. Bit of blue tack. Hold it in place and get it roughly straight. You need a switch with so many positions. Maybe it has modes. Okay, that's in place. Let's get this blue tack out of the way. Right, we have a switch. Oh, it's only 2 positions, it's just double ganged. That makes more sense. It's just an on-off switch then. I see. Oh, cool, you're doing some research for me, thanks. Yeah, it's a double gang power switch. It's just got... It's not double gang at all. It's actually just 3. There's only 3. Okay. It's starting to make sense. So now what? I've got an LED, and I've got a little... I assume this goes here, but that means I have to bend these legs. Let's see if I can just... There we are, that's gone alright. So it's USB power. Oh, they've used micro USB. Boo! Are we flush? Please be flush. Not particularly flush. And now I've squeezed blue tack into the inside of the port. That was silly of me. I need to tidy that up in a minute. Making a mess of it. Never get on well with blue tack. Okay. This is our power socket then. Power socket is in place. A little bit too much blue tack involved for my liking. Sure, it'll be fine. Okay. Oh, we've still got this LED to go in. Positive and negative then. Here. So I've got the diode pointing right to left. Left is clearly ground. I mean, positive goes on the right, and the negative goes on the ground side. That would make sense to me. I'm going to sanity check that. Yeah, that's right. Positive on the anode side, yeah. Okay. I don't know if this is a status indicator or if it's like an onboard LED for your first sort of blink code. I'm going to go with the latter. I don't know for sure. Okay, we're on to the next bag now. Bigger bits is what I'm calling this bag. a speaker... Does this speaker have a polarity? I don't think so. I'll just copy the picture. Speakers are very topical for me at the minute. I've got a video uploaded, ready to go. I'm just waiting for the sponsor to approve it. And it's all about the beep routine in the Specky and how it works. And I tell you what a rabbit hole. It's a bit of an epic voyage. It's a 50-minute deep dive into assembly code and the minds of the developers when they came up with the ROM routines. But if you like really boring, overly detailed stuff, keep an eye out for that video. Speakers in place. This is our composite video. There's only two. It makes sense there's only two, but why have they given me 4 connections? Maybe they have different packages of connector. That must be it. I only have 2 joints to make here. Let's get this one in and then try and line up. That's pretty straight to me. I might just snip these tabs down a bit too. God, this is going to ping off. We're getting there, taking shape. This is a keyboard connector then, USB-A. Just do the middle leg there. Let's try and get straight. That looks good to me. Did you find the docs in English by any chance? Okay, just headers now, I guess. Now, what is this? Some sort of serial data? I don't know what that is. Something for external devices, I guess. Is it going to behave and stay in place? I'm going to go with no. Make a mess again with some blue tack. Oh, cool. That's good to know, thanks. Is that straight? It's not really straight. Hang on a sec. Okay, good enough. Be cool if we could get a blink program running on this. LED 1 is going to a pin called LED actually. If we control that pin, I think it should be fairly easy to get it to blink. That's nice and straight. I'm already trying to think of things I could use this for with the Specky to make daft gizmos. But then I guess anything this can do, so the Specky can do better. So slightly worried about my microphone receiver. I'm using a wireless microphone at the moment, and the battery's getting a bit low on the receiver. How long they're meant to last for. Something tells me if I plug it in and charge it while using it, there'll be a lot of interference. I don't even know if you can charge it while using it. Probably deal with that. Let's do an experiment. I'm gonna put some power into this USB, this microphone receiver, and I'm curious to see if it still works. Feed these cables around. Okay, I might go mute here. Let's see. It's plugged in. It's charging. Tell me if there's loads of interference or not. If you can, please. I think I might have found a solution there. So, back to the build. Well, the build is finished, isn't it? That's that. That's great. Okay. So now I need a power source, which is just going to be a micro USB cable. Let's have a look. I've just bought some of them because I was messing around with the logic analyzer. Yeah. I'm going to use, where are they? Rifling through the drawers. Try this one. Thank you. Thanks for confirming. Okay, USB power. There. Turn the soldering iron off. I'm going to start melting all these wires. And I should be able to turn that on like that. On. It beeped. I don't know if you heard that. It beeped. That's positive. Now here's the question, is there anything on the terminal? Oh, that's flimsy as. God. Yeah, hang on, I'm bringing you up. Is this a good... There it is. This isn't a very good lens for this because it's massive. Okay. It works. Turn these lights off. Ichigo Jam Basic 1.5.0. How nice is that? Alright, give me a sec because this isn't a very good lens really. I'm going to nick this lens, so you're going to go blurry for a second. I'll pop the massive lens on here. And this little diddy lens should give us a better view of the screen. That looks a bit better. I'll switch it back over. Nice. So I need to dig a keyboard out. Give me a sec. I've got one around here somewhere. Yeah, this is the one I use with the emulator. Yeah. Cool. I can type. But I don't know anything about this, how to make it do anything. Is there a print command? Can I just make it print to the terminal, to the output? Yeah, apparently you can. We in caps lock here. Print. This gonna work. There we are. That's the first program. Lovely. What I should really be doing is a video capture, and you can see the device down here as well, but let me try this. I think there's an LED command. LED 1. Amazing. So you can't see that. Just a second. That's not very fair. Over the shoulder. This will be challenging for you to see everything at once. But let's try. So here's my keyboard. There's some light. And if we type LED 1, then I'm going to hit return. This is intense. I'm so excited. The LED turns on. LED 0. Oh, it's not case sensitive either. That's nice. So, can I do line numbers? 10, LED 1, 20. I wonder if there's a pause. Is there a pause? Or a wait? There's a stop. Oh, there's wait. Let's do wait 1. 30 LED 0. 40 wait 1. And then what do we just type? Run. No, I'm doing that wrong, obviously. Ichigo Jam basic command list. Okay, I'll just scoot over. Let's have a little look. Cute. Oh, I see. Yeah, this is the same document I've got here in front of me printed out, but it's mine's in Japanese, which is less useful. Okay. I found a little guide on the lighting the LED on and off. You can type in line numbers and make it do stuff. I wonder why that didn't work for me. Oh, it would have just done it really, really quickly. I need to do a go-to, don't I? Is there a go-to command? Yeah, there is a go-to, I think. Yeah, go-to. It's just like basic. 50 goes to 10. Okay, so that 1 isn't 1 second. That's flashing really, really rapidly. Escape breaks the code. That's good. So let's overwrite that with... We need a longer wait. I just overwrite 20 like this with wait 60. And 40, it's 60. I wonder if there's like a list command. Yeah, there's the listing. So I should be able to run that now. Yeah, now it's blinking. This is fantastic. And the next question is, how do you get the speaker to do anything? Beep. Beep. Number. Wavelength and duration. So what if we made it beep while the LED is on? 15, beep. I don't know, 100. $60. Oh, I need this. This should overwrite the line in 20, shouldn't it? 20, beep, 160. 40, beep, 160. So let's look at that. LED on, beep for a second, LED off. I want to change the note when I do that beep. So 40, beep, 20, 60, run. That hasn't worked at all. It's just making crazy sounds. Why was that going around so fast? Oh god, it's gone Japanese. How did I do that? That was interesting. Beep. 100, 600? Okay, I'm obviously getting this beep thing a bit wrong. Caps lock seems to make it type in katakana, which is quite difficult to code in Japanese, I guess. Maybe I do need the wait. What does beep do? Beep just makes a little beep. Beep 100. Beep 5. Beep 10. Beep 15. Okay, it's going lower pitch as I go up. What if I do beep 15, 1, that's very short. Beep 15, 10. and beeps for a longer time. I think I'll change line 20 to beep 1560. I'll change line 40 to beep 560. Run that. Still going crazy. It's no good. Maybe I do need the weight, so let's put the weight back in. Weight 60. 45, weight 60. That should work. Can you hear that? I don't know if you can hear that, it's very high pitched. But it is beeping in time with the LED. Lovely. Should we try this play command then? Let's break that code. Play. Let's look at the reference. I guess we're looking at the same document now. So let's just try C. Where's the C? Where C, D, E? That is playing a song. What does the dollar do? The dollar seems to make it persist. Hope you're hearing that or not. I guess you'll be able to hear it in the background while I'm talking. The noise filter will probably be trying to get it out. I don't know how to stop it. Okay, that stopped it. What if I do a dollar then with CDE? Ah, it just makes it loop and loop and loop. Interesting. So can we try play? Let's do Beethoven's fifth. So E, E, F, G, G, F, E, D, C, C, D, E. D2. Hang on, I don't understand the note lengths. Wait, I need to experiment. What does D2 do? So that's twice as long. Can I do D 0.5? No, you can't do D 0.5. It's which bot? Lovely. Okay, so maybe I need to do then, if I want to play Beethoven's fifth properly, it's going to be very slow, but... no, F. D, 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 D4, D, no, E3, and then D2. It doesn't really work because there's no stop in between each note. Play. Let's go with that. Hope you can hear it. I'll bring it up to the mic. Well, that's fun. Is my code still in there? Yeah, it is. Oh, possibilities are endless. I guess let's try this switch. This should reset it. Okay, reset. Oh, it's not a reset then, is it? This must be detecting inputs. Excuse me. So maybe you can have the switch which turns on the LED or something like that. That's fun. I'm excited to have a look at what everyone's been doing with this, because as I said, in the sort of tech mall that I was in, the guy had little like MIDI interface keyboards playing songs and things like that, which was great. That's really neat. I wonder if you can buy them over here. But it does say only for use in Japan. What's this here? SCK. I guess this is for interfacing with the microcontroller. There's a little header over here. If you want to reflash it, that must be what that is. You tidy up a little bit. Because I've made a right mess. I think we've done well to build these three things so far. It's one I can just turn on and off whenever I want. And we can watch him flashing. I'm going to come up with something else to fix up now. Let's see, I've got the stickers here. Oh, the stickers must be for if you want to put it in a case. That'll be what that is. That's these ones here. I'll keep hold of them. It could be useful. Let's keep it in its original case. The original bag, I should say. Probably slot the stickers into there. Keep that in there too. That with the pile of bits that we've made. There's a bag for the bag drawer. Very organised. This is all junk. And I don't need this, that was the power for it. Don't know what I did with the little twisty tie that was holding this bag together. Probably just throwing it on the floor. Maybe I can get this around it. That'll do for now. Right, I'm still keen to do something else. So let's have a look at what I've got on the pile. Let's fix something up. Which one? What have I got? Let's look at this. I haven't looked at this one yet. We stepped up the complexity a little bit from Christmas decorations, but this is a 6A, issue 6A ZX Spectrum. This has come... Yeah, I guess there was no case with number 12 as such. Can't seem to find a case, so this is going to need a case when it's done. It's obviously come out of a Spectrum Plus because it's got the reset switch here, and it's a later issue board. What does it say here? Corrupt. So I'm going to guess that this is going to need some chips replacing. I think we should take the reset switch off for a start, because that's just going to get in the way. My soldering iron's cold. Mate, let's let that heat up. Why is Stream Elements telling me that? Has the Twitch stream restarted? Doesn't really matter. No one watches on Twitch. It would be nice to get a bit of a following on there. Iron is heating up. Iron is hot, so this should melt. Yes, it's melting, that's good. Right, there's our switch off. We'll keep that to one side. So what do we do first? First thing we do is we check power supplies. These lower RAM chips need 3 different voltages, which is fantastically painful sometimes. So what is the resistance of the -5 supply to ground? 3.7k. That's good. It means it's not 0. What about the 12 volts? 2.5 kiloohms. That's also pretty good. And 1.1 kiloohms, the 5 volt supply. So we can probably power this up and measure the voltages. I wouldn't normally do this, but my bench supply is in use, so I'm just going to plug it straight in. And we can measure these voltages. Voltages are completely wrong. That should have been -5 volts. So what is going on there? Maybe I should have used the bench supply. Oh, okay, bench supply. I'm gonna have to unplug this screen again. Let's knock it down to 9 volts and change the polarity. So these are center negative. Put a sensible current limit on it. It's on 2 amps at the minute. Let's go right down to 0.4. That's good enough. Okay, it's not drawing too much. It's drawing 400 milliamps. However, 400 milliamps is less than I would expect. So I think something's not right. Let's check. I didn't get a chance to look at the 12 volts. These RAM chips don't like being powered up for too long with the wrong voltages. 12 volts is 1.2. God, 5 volts is right. So something's wrong with the power circuit. I don't know who's written corrupt on here. Maybe they had a look at the video output before checking the voltages. So what we're going to do, we're going to check TR4 and TR5 for a start. Those are the 2 transistors in the power circuit. And I think I'm just going to remove them. Not mess around trying to measure them in circuit. Where's my solder sucker gone? There it is. Alright, here's my solder bin. Let's get these transistors out. Pretty sure this is where they live. Well, that didn't go very well. Let's add some solder, just to make things a bit more compliant. We're getting 5 volts, but we're not getting 12. It means there's either a problem with these transistors, or the RAM chips are pulling down pulling down the voltage because one of them would have an internal short, but the resistances didn't look too bad when we checked them. I'm not really suspecting them. My first guess is these transistors, which should come out nicely now. And get these legs free. Two free, and come on now. There we are. This is not coming out because of the pins are bent around. Okay, that's the ZTX 650 out. That's TR4. And let's get TR5 out as well. Flip around. TR5 lives over here. Let's give this a waggle. It's two legs free. Yeah, I think that's all three legs free. Yeah, we're out. If we go into diode test, you can see if we're getting the right voltage drop over each of the junctions in this transistor. Can't really see that, can you? Sorry. So we'll put negative on the middle leg first. This is TR5, which isn't necessarily bad. Yeah, that looked pretty good. We got 0.7 volts voltage drop. Yeah, that transistor's okay. Let's try TR4. Dead short. TR4 is gone. So, luckily, in this donation pile, I did get a big pile of transistors. You have to bear with me while I go digging. There's a ZTX 651 bag that will contain TR4 replacements. And let me find a new TR5 because that can't hurt either. I have to rummage around in the straw a little bit to find them. Diodes, no. No. Come on now. Oh no, they're in here somewhere. What's that? There's a box of bits. Resistors, capacitors. ZTX 450, that's the wrong one. That's all screws. Don't need any screws. We will put a voltage regulator in it. That'd be nice. Find it. Where's my bag of TR5s? It seems to be showing up. Oh, not to worry, I'll just dig one out of my own supply. In here somewhere. Yeah, ZTX 751. That's the one. So there's our TR5. Don't really need to replace this, but I'm thinking, you know, why not? while we're at it. Need to open up this joint a little bit. Still some little dags left. ITX751. Let's put this weird song on again. Come on now, behave. Okay, that's in. Let's just put that one in so it doesn't jump out while we're getting the next transistor ready. Don't like this song, I'm gonna skip it. I'm running a meditation class. Okay, so ITX651. Let's make this do the splits a little bit. Make sure I get the orientation right. Flip it. I've got a feeling this is going to restore the voltages, but if it's been ran for too long, bad voltages, we might have lost the lower RAM chips. Which is always good. But I wager this is going to start drawing a little bit more current. Oh, straight into current limiting. That's bad. What does that mean? Let's just check these resistances again. Means that something's not happy. Resistances look okay. But why are we current limiting? I didn't cause a short there. No, nothing wrong there. Nothing wrong at all. Sometimes these capacitors can go bad, and that can cause a big over voltage on 12 volts. I'm wondering if one of these chips is shorting out somehow internally. And I'm tempted to have a look with the thermal camera. That's this one. I pop this in my phone. And we can go into the camera app. Hopefully, screen's dirty. We get a thermal view. And I'm curious if any of these chips light up. Yeah, See these two chips here? This one and this one, immediately glowing hot. Much faster than the other ones. So which one is that? That's IC8 and IC3. I also want to, shouldn't really do this, but I'd love to know if it's getting over voltage on 12 volts, which can happen when these capacitors go bad. Where are my multimeter bits? Let's just do a very quick measurement of this on here, and then I can clip that onto there, the ground. I can hold this on 12 volts. We can have a quick look. It dropped down to 5 volts very quickly. Yeah, it's hard to say really, but I've had machines where the RAM chips just cook, absolutely cook one after another, because there was 20 volts due to these capacitors going bad. But maybe it might be a good idea, just to get ahead of the recap game, let's change these capacitors. Oh, what was that big chunk of metal that just fell out? I wonder if that was shorting it. Well, I've cut these now, so let's replace them. That's the wrong leg. That's the leg I wanted. That's one out. Two out. Whoops. And the leftover legs. You can melt if you like, please. One leg out. Two legs out. Lovely. It's a bit beefier, that one. That's a ground joint. Alright, and I know I've got some recap kits down here. Where did they get to? I had bags of them. Here we go, here's one. There's a load of capacitors, they'll do. These big fat ones should be 100 microfarad. Yeah, they are. Absolutely massive. Probably slightly too big package really, these ones. They do tend to touch each other. not unusable. Alright, that's those replaced. So if it was getting over voltage and causing a problem, I mean the problem might already be caused, but at least we've eliminated that possibility that these were causing 20 volts instead of 12 volts. I bet we're still current limiting. Yeah, still current limiting. So I'm going to say these chips are bad, and we can either just remove them, or I could start cutting the power supply legs. And since they're probably bad anyway, I don't really see any harm. Just remind myself, was it IC 1 and 8? Is that what sorry, IC 13 and IC 8. Have another look at these lighting up. Yeah, pretty clearly this one, that's IC 8 and IC 13. This area is hot from soldering. IC 8 and 13. I'm just going to cut the power pins. Make sure they're clear. Oh, this seems a bit brutal, but I was going to cut them out anyway. I'll leave ground connected. Let's see if we're still limiting. Now we're not limiting. So they were definitely causing the runaway with the current. I wonder if we're in a position now to get the right voltages. Let's see. We're not current limiting, that's good. Let's see, 5 volts, yep, 5, 12, 12.4, and -5. That's good. The current draw is still a bit too low, I think. It's 0.49, so something doesn't quite seem right. But we've got the voltages back, which is lovely. It means these chips need to come out. So I've started cutting them. I'll just cut them out. You got to cut very close to the body of the chip here. Otherwise, what happens is you damage the joint. You need good, sharp snippers. Mine aren't the best. I do get them sharpened every time we're at Repair Cafe and the tool sharpener is there. That's him out. What was the other one? It was this one on the end. Come on now. Last one. Okay, it's out. Now we need to remove each of these legs, and this is the bit you got to be really careful because you're pulling on one joint at a time, and you can you're not careful enough, lift traces doing this. We're just going to be patient to make sure that the joint is fully melted before pulling. It comes out with very, very little force. In some ways, this is easier than removing the whole chip, but I don't think this should be the default method unless you're totally certain that you've got a bad chip, because it's always nicer to gracefully remove the whole thing and test the chip separately. You don't have to throw out a working chip. Oh hey, how's it going? Brizzle, thanks for coming in. Yeah, I've done that before, and that sucked. Some of these boards, I don't know what it is, but some of these 48K boards, they just fall to pieces. They're just made of meringue or something, and the wires all fall out. I don't know if it's just because when people send me repairs, it's normally one that they've had a crack at themselves, so everything's already been cooked. I'm getting there slowly. Yeah, I know what you're talking about there. I find this one up here on this capacitor, it's connected to a massive ground plane, and it just needs a hell of a lot of heat. And that does make the solder mask all start to deteriorate as well, which kind of sucks. For clearing joints, I prefer actually, if I'm doing capacitors, to hold it upright in a vise, and then I can heat from one side and put the solder gun on the other side. This one doesn't want to melt. Come on, baby, out you get. I heat the trace a bit first. Yeah, this one's clinging on for dear life. I'm gonna add a little bit of extra solder. Yeah, now he's moving. There we go. Crisis averted. Thing with a vice grip is you need something good to hold it by, so I grip it by this modulator box. You don't really want to be obviously gripping delicate components or traces. I had one of these in once. Someone had been working on it and it stopped working. I found a break in the trace here, and they'd been using one of those workstations with the 4 alligator clips. And even with the alligator clips protected with rubber, it still managed to break that trace. Totally rendered the whole machine useless. You need to be careful with those things. Okay, we're halfway through. Let's do these ones. That one was awkward. Finding it hard to get hold of these guys. Maybe it's the angle I'm coming in at with this chip next to it. Three more here with this this chip. Drop that right onto the board. I reckon this board has been subjected to a edge connector mishap, the way it's failed. And this is ground, this one. It's putting up a bit of a fight. Take a bit of solder on there just to flow around. Okay, he's out. Right, just these other 8 over here now. There's little legs everywhere. Last one. It's a ground, so let's have a bit more solder to help. And drop it. And solder's just balling up. Here he comes. Okay. We're out. Now we can clear the joints. I do have a Duratool gun here, but I'm too lazy to turn it on for just clearing some joints. If I was removing the chips properly, I would have used it. And what we'll do is we'll stick a couple of sockets in and replace these chips. I've got a box of the chips in the drawer. Quite nice to use a thermal camera for repair. I've never successfully got a chip out just using the wick. I find it doesn't, I can't get it to like clear around the joint. Maybe I need more flux involved or something. I always resort to the hand pump. What's this one here? This is a ground, isn't it? That's why it's fighting me. some extra solder on there. There we go. Wait. Then, of course, the damn hand pump gets clogged. We're getting away with it so far. It's getting a bit sticky. There we go. It's a nice big tube of solder just came out the end. It's a bit more stubborn because it's a supply joint, power supply joint. Same with that one. Oh, that didn't get it. Let's put a bit more solder in. Lovely. Now, having lost 12 volts could be bad for the video circuit because I think the LM chip uses that. Hoping we didn't lose the LM chip at the same time. Oh, I think the solder pump's losing a bit of oomph with being a bit clogged. Let's just add some solder to these. Yeah, that's good. And this one. Okay, we're all clear. That's good. How about some sockets? Oh, that's edge connectors. It's the wrong size socket. About it, I was a bit low on these sockets. I wonder. I hope I haven't run out. Oh, come on now. At least tell me I've got the chips. 4116, yeah. I've got the chips. That's good. Sockets, however. What's happened? I had some. Where have they gone? I'm wondering if these are going to fit. I've got some here. No, they're too big, see? 18. Yeah, we don't need 18. We need 16, don't we? Oh, there's a 16er. I've got one. What's that? That's 14. That's no good. 14. 14s. Lots of 14s. So many 16s. They're all 18. Might have to solder one of these directly to the board. Which wouldn't be ideal, really. Don't like doing that. I've got a 3 and a 4. Is this acceptable? No, that's not right, is it? That doesn't add up. I need 2 4s. Okay, a bit of a MacGyver job, but I could do this. It'll work the same, eh? That's fine. I'll do that. You have to improvise sometimes. I'd rather do that than leave it without a socket, just in case I do manage to fry it again. Alright, let's do this then. Let's first of all get this socket in place. I'll just bend these pins a little bit. Didn't fall out. Shouldn't fall out. Let's just put one on this side in. And one on this side in. I can push and melt each one in turn. Hopefully that's flush, yeah, that's pretty flush. Yeah, if it works, it works, absolutely. And let's pop this one in there. We do these 2 4s individually, I guess. One, 2. Careful not to burn my fingernail doing this pushy bit. That's good enough. And this one. And bend the pins. Please don't fall out. We joints doing this. Be extra careful. Sort of not expecting this to be the last thing that this computer needs, given that it's had a fairly major power circuit problem. But we can be optimistic. Maybe it'll be fine. Let's pick this bloody Pink Floyd song again. I'm gonna skip it. There's our new sockets. That's a bit on the piss actually, but never mind. A couple of 4116 chips then. I'm going to assume these work because they're in the new pile. One in. Okay, that putting up a little bit more of a fight, but it's in. These back in. Oh. All right, now what sort of current draw are we getting? 500 milliamps. That's okay, I guess. Seems a little bit low. Those are my transistors. Let's put that up there. I'm gonna say that our voltages are probably fine now. Let's check. No, they're not fine. Why was that moving around so much? Maybe I just wasn't pushing it right. -1. -1. Oh god. Alright, hang on a minute. Something's not right again. Let's take those out again, because before we put them in, the voltages were correct. Let's try again. -5, 12, 5. Is there a short? I don't think there's a short. Those are meant to be shorted, that's the data bus. I don't think there's a short. But what's gone on there then? That's very strange. I wonder if these chips are definitely good. I've got a chip tester somewhere. Is it in here? Yeah. This is 9 volt center positive, so I'll flip the polarity on that. Power supply. Plug in the chip tester. And it always says failed this on the first couple of tries. It seems to just be failing. Let's try this one. Right, that one's actually running the test. Blinking away. So that one's good. Couldn't get this one to run. Right, now it's running. The fact that it's even running, yeah, it's passed. Let's just try putting 1 in then. And I'll have to swap the polarity back over because the spectrum's sent a negative. Still drawing quite a low, oops, quite a low current really, 500 milliamps. Now we're getting the right voltages. What if that chip in that socket looks good. What about this chip in that socket? -5. Okay, so now let's go back into this socket. -5. Now we've got the right voltage. Okay, I don't know what was going on there. Let's not touch anything. Let's just see if we're getting anything out. Video-wise. Got composite cable here. I'll just hold it up against the side first rather than doing the composite mode for a quick look. Yeah, there's the screen. Power on, and I'll hold the cable on. Hey, how about that? Nice. It works. So, what do we need to do? Let's do a quick composite mod. And we can just leave the cable plugged in and see what's going on. Well, I feel like that's quite lucky. Hang on. We don't need this corrupt sticker anymore. Yeah. Yeah, it's a nice feeling, isn't it, when it comes to life. Put these connections off the modulator. Lost count how many times I've done this. I like your strong emoji use. I've got some custom emojis actually, check these out. Oh cool, you're in Twitch actually. Nice. Thanks for watching on Twitch, it's good to know it works. I think my demographic is more YouTube based. You're in the advantage there because you're getting the lower delay. There's a big delay on YouTube and I don't know why. Right, let's get this resistor off. Okay, that's off. 100 microfarad capacitor, please. This one will do. I don't know if you're a follower, but if you want to help me out by testing the alerts, that would be great. See if you get the pop-up and the little song. Clicking follow. Sounds like a really bad phishing for you to follow me, but it's just a test. Okay, that's those joints cleared. So now we can put the composite mod in. I never remember what the... Hey, it worked. Cool, thanks. Good to know. Positive into the board. Thanks very much, that's appreciated. So we put the positive leg into the board, and I spent ages on those alerts. Half the time they don't bloody work. The negative, we need to sort of jimmy into this, into the hole, the insulated hole in the side of the modulator case. So in we go. Are you a Spectrum fan? Have you got these? Have you got one of these? Right, there's our capacitor in place. Is that soldered in? Where's my snips gone? There they are. Ah, C64, cool, yeah. No, I don't take sides, although I've got in firmly in bed with the Spectrum crowd. Just never tried working on a C64 yet. No reason. Just fallen into this rabbit hole, and plenty in here for me to play with without bringing more computers into the mix. So that's a composite video mod now, so we don't need to use the RF tuning or anything dodgy, so I can plug that in there. And I can see... Hang on a minute, we got a bad power jack. Oh yeah, that's diabolical, okay. Let's replace this power jack. Hey Rudy, welcome in, how's it going? Thanks for joining. We've had a good time today, mate. We've been building. We've built a little... I bought some kits. I bought some kits from Tokyo while I was there, from the electronics department store, and we've built them all. Like a little flashy LED thing, microcontroller, a little stable, simple oscillator for the snowman decoration LEDs, and then this is like this is cool. It's called Ichigo Jam. The Japanese, like really basic, I don't know what you call it. It's like an Arduino. It's a microcontroller. It's got a video out. It's got its own terminal. It's got its own basic, and we were making little programs to make it beep and turn the LED on and off, which I thought was really cool. Anyway, we're fixing this up now. So we've fixed it. We had a bad power circuit, and these two circuits were cooking themselves when we turned it on, so that's fixed. Just done the composite video mod, and I found that the power socket is really bad, and this is where I'm gonna block my this is where I'm gonna block my solder sucker, I guarantee it, in removing this. This is a messy, fairly beefy job. So here we go, I'm going to block it in one. Yeah, it's blocked. Get out. Oof, God, this has really blocked it. One ROM, I think I've seen those. Why does the colour red come into my mind? Are they red PCBs? Oh my God. I don't think I've ever blocked it this bad before. Can't even get the end off. Oh, there we go. Ooh, I've just showered solder dust everywhere. Okay, yeah, I have seen them. Bear with me, I'm just battling with my nozzle. Is it clear? No, not really clear. 10. What sort of footprint are they? Are they? Do they work with a Spectrum? I think I've seen them do it for Amiga and stuff like that. Oh God, this isn't good. Maybe I need to get the solder gun out, the glue gun for this. There we go. Oh, that was a big one. Don't even know where it went. Okay, we're clear now. Let's block it again. Oh, it didn't block it, that's nice. So hopefully I can just melt this joint and it'll come out. Prop it up on something. Hang on, I need to make sure these legs are free. They're definitely not free. Oh man. Four pins. Oh, cool. Yeah, that's nice. I've got a similar thing here that Retroleum makes, and it fits in the Specky. It's got a switch on it. This one, you see it's just a ROM chip with a switch on it. This thing contains 2 ROMs, and normally you load one with a Specky ROM and one with a diagnostic ROM, which is handy. Right, what was I? Yeah, freed up one leg. I think I've freed up 2 legs. Mind your fingers. Yeah, we're out. Here's one I bet you haven't seen. I'll make a video on this very soon. The drop-in Z80 replacement based on the Raspberry Pi chip. He's configured this for us for me to work in vanilla, just Z80 emulation mode, but it's a bit like a Pi Storm. You could do all sorts with this. You could use RAM, you know, replace your RAM on board, peripherals. I reckon you could probably get a HDMI feed out of it as well by bus sniffing. But anyway, yeah, interesting. Thanks, Rudy. That's very kind. There's a painful video coming out soon. It's already uploaded. I'm just waiting for the sponsor to approve it. We're gonna pick apart the Spectrum beep routine, and I really went overboard on this one. It's really long-winded and detailed. If you're into that, then maybe you'll like it. How stuff works, sort of thing, but taken to the extreme. Right. Can I get this in flush and straight? Don't fall out, don't fall out, don't fall out. Cute. No, that's wonky. We're not quite there yet. Hang on. That'll do. That's closing it. Always feels like I'm feeding so much solder into these joints. And they stay molten for ages. Okay, that's going to be much better. So now I hope we get a nice stable power connection. We get a good screen, yeah. We can run a diagnostic ROM. I don't have a giveaway to do at the moment. I thought maybe a 10,000 subscribers event could be good. To be honest, the last one where I gave away the Amiga boards, it basically cost me about £200 to do that because of the boards and the shipping and everything. So maybe I'll do one, but maybe not giving away like such crazy high value stuff. They are fun. A little bit painful sometimes when the game doesn't behave itself, but they are fun. I'm going with a Dandinator. I haven't cleaned the edge connector. I hope it's gonna be good enough. If I hold this button down while I plug it in, it should start the diagnostic routine. So I'm going to point you at the TV because I don't have a capture. Let's turn the lights off. And yeah, those boards, like, they were about £50 each, I think. And would you believe it? One of the winners was in Australia, of all places. It couldn't have been much further away. Okay, so we're going to try diagnostic ROM. Cross your fingers for me. Okay. That's not so good. Right, hang on a minute. I think we may need to clean this edge connector. So let's get the heatsink off. I've got a big pile of these heat sinks because the person who donated all of these had intended to fit Tracos, switching regulators to all of them. And so I'm honouring that and doing it. It means I've ended up with, yeah, lots and lots of heat sinks in a pile. Now, forgive me, I'm going to cut this out because I wouldn't reuse the old one. We'll put a Traco regulator in since we've got the heatsink off. Let's get round here. Get these legs out. Lots of leg pulling today. Middle one's ground, isn't it? That's why it's not coming. Here it comes. Come on. Come on. Come on, get out. Ah, screw it. Let's put some extra solder on. I'm gonna get impatient here and I'll end up damaging it. There we go. He's out. And the output leg out. Yeah, I don't know, people are a bit divided on whether or not you should do this. I like the new ones. I mean, you lose the authentic weight of the Spectrum. You can cut the heat sinks down, obviously, if you wish. Well, here we are. Do I get this out again? Hit these packages. Okay. Make sure I get this the right way around. This is a wonky coil. Look at that. Battery's about to go again on this camera. Hang on. I'll flip you over to the shoulder view while we continue. I see the point in making this look neat with that coil so wonky. Well. Right, I've got a fiberglass pen up here. Looking a bit fluffy, to be honest. I'll give it a snip. Well, that's made a mess. Don't breathe this. Oh, I think this one's actually pretty much run out. Oh, bugger. Okay, I've got another. These aren't cheap, these fiberglass pens. They do a good job of cleaning edge connectors. Feel a bit of a brutal act. It has been well used, this, by the look of it. Got those black marks along each of the pads on this edge connector. Hopefully that'll do. Let's get some alcohol on here. Okay. With any luck, maybe I can just point you up here, you can see the TV. You see that? Try again with this ROM. Let's see why it wouldn't run. It must have just been the edge connector. Yeah, we're in. Hang on, there's a bit of glare there. So, if I hold down the button, good. Cross your fingers, please. Lower arm passes. Lovely. Looks like it's passed all the tests. Which means we're gonna need a case for this one. I've got cases somewhere. Yeah, we did it. Nice one. That's amazing. We should check. We should check if the M1 line on the Z80 is working. Sometimes the M1 line fails and you can't tell unless you're using a peripheral like this one, which needs it to work. So, please. Yay, it works. Even the M1 line works. Perfect. Not much to do then. Let's just try the keyboard and that. Let me find a keyboard that works. I had a test keyboard, but Typical of me, I ended up fitting it to a repair job. Keyboard. Woo! Let's do... We can do the diagnostic tests properly now. We've got a keyboard in. Let's bring you back overhead. We'll get a better view. Oh, I didn't change the battery. Hang on a sec. Right. Should be back now. I can turn the soldering iron off. That's nice. All right. Power. Do some ULA tests. Works. Yeah. I could show off my rumble pack here, but I'm not going to do that. I can't be bothered getting everything all set up. But I don't know if you saw the video, but I made a joypad that vibrates in reaction to events in the game, which is probably the best thing I've done. And unfortunately, I hid it in a video which hasn't done very well. What's this? That's Sinclair. That's a magazine, isn't it? Sinclair Abuser. I did finish this game once. I don't think I'm going to get into anything else today, so I'm going to play this for a little bit and then finish up. But we've been going for 4 hours and we've built 3 things and fixed a specky. Is nice. I'm going to show you. Let's have a look at these things I made because I'll play with them again. We have, first of all, Christmas decoration. That's our little snowman dude. Dead simple. I thought we could modify it actually by changing these capacitors or the resistors to speed things up. So he's happy there. This thing, I can't really power this up to be honest without messing with the bench supply, but this is a tiny microcontroller. The lights on. Tiny microcontroller, just 8 pins. It's not going to focus unless I come out. It's got 2 pots to adjust the colour and the rate at which it flashes. And that's all it does. It's simple but quite satisfying. And also the Ichigo Jam, which I thought was super cool. This is the little... I think in Japan they make it for kids, but I'm not sure to be honest. It's basic. It's basic and it's a bit like an Arduino, but what I really like is it's got its own terminal. Plug this into here and get it takes USB power. Where's my wires gone? Here's one, this'll do. Give it a bit of power. We have, look at this, Ichigo Jam Basic, which I think is mega. And you can just type basic listings in and make the LED flash and the speaker beep. I saw it in a department store which is totally dedicated to electronics and tinkering things, which was amazing, in Tokyo. And had a little awkward conversation with the guy who was trying to sell these. He had them set up as like little music things. You could, little MIDI interface keyboard plugged into it and stuff like that. Oh, thinking what you could do all sorts with this really, because you've got all the inputs and outputs to play with. Speaker on board, LED on board, USB keyboard support. I think that's amazing. I'm going to do a bit of looking around at what people have done. There's a button as well, so you could like turn the LED on and off and stuff like that. Yeah, I thought that was cool. Yeah, and fixed up a computer. This is going to be going on eBay as well for the charity. For the guys donated all of these. I don't know if you saw the video, but a really huge box of Sinclair stuff, Spectrums and parts, cases. So I've initially fixed up 3 of them and sold them. And it's all going into a Just Giving page for a UK charity called Special Effect. And we're up to about 600 quid so far raised. So this is going to go on eBay once I need to change the rest of the capacitors and finish servicing it. Other than that, there's a video about to go live tomorrow where I fix another one of these from the charity box, and that'll get sold to charity. But yeah, that was a machine that wouldn't beep, so I decided to learn how the Spectrum beeps in extreme detail. You can watch that and learn how the beeper routine works. And yeah, this whole place looks like a bomb site now, so I'm gonna go off and I'm gonna tidy up a bit, I think. I probably need to cook tea tonight too. Start thinking about that. I imagine my cat's complaining by now that she hasn't been fed. Oh, let me scoot back over to you guys over here. So that's it. I'm going to go now. That was fun. Might do that again soon. Just a building things stream. Tinkering. Oh, we almost fixed a power supply as well. The power supply to my little screen stopped working. Replaced a diode in it, but I didn't have quite the right spec of diodes, so maybe I'll order that and we can fix it in the next one. Thanks for joining us, Brizzle, and everyone else. Rudy, if you're still there, have a good day. I missed your alert. I'm going to play it again. Is he going to play again? I've just replayed it. These Twitch alerts are so slow to come through. I guess it's going to come tomorrow or something. All right, thanks guys. I'll catch you in the next one. Take it easy. Have a good week.